Hello, thank you for coming. This is Brandon from Akamai Technologies. Originally, I submit this session proposal as a 30-minute tech session, but it was accepted as a 5-minute lightning talk. So I had to condense my contents and update the title accordingly. So today, I will talk about how we can schedule and orchestrate the GPU allocation for AI machine learning service on Kubernetes. So let's get started. So thinking about why we learn the AI machine learning on Kubernetes. So based on the community research, so Kubernetes has become a key platform for AI machine learning. Based on the research, is more than 30% of AI machine learning pipelines are running on the Kubernetes. So as you can see, so year by year, the percent of the utilizing Kubernetes has been increased. And thinking about the reasons, so the Kubernetes provides a unified infrastructure for AI training and inference, and thanks to its ecosystem, so portability across the environment and scalability and high availability can be supported on the Kubernetes side. So that's why we learn the AI on the Kubernetes. But in reality, we have GPU allocation challenges. So you know that the GPUs are so expensive, and if we order the GPU today, you need to wait for a few months at least. So AI training today demands a massive compute, and AI jobs now require tens to hundreds of the GPUs when it comes to enterprise level service. So that's why I designed this session. So another challenge is the GPU fragmentation issue. So single GPU pod scatter GPUs across its node. So it means that if we don't have any strategies for smarter GPU allocation, it means that we will waste our GPU resource for our application on the Kubernetes. So we experience very frequent pending jobs when we use the GPU on Kubernetes due to fragmented GPU allocation. And we experience also GPU's idle time after job completion. So even though we have the smart open source tools like the Kubeflow and the Argo workflow, they excel in workflow automation. But however, GPU utilization and scheduling remain suboptimal, even though we use this kind of the open source. So right now, the optimizing GPU utilization and scheduling is now one of the key areas in modern MLOps. So let me choose the GPU monopoly example. So by habit, when we announce the job, using the Kubernetes with the NVIDIA GPU for an example, we use the resource tag and the limit tag with the NVIDIA.com, the GPU and numeric value to assign how many GPUs will be assigned to this job. So by habit, we put 1 or 2 or 3 the GPUs for this AI job. But this is a common GPU assignment pattern, but this allocates the full resource of one GPU unit to this pod. So I have an example. So it's as the same as there are, if you see the pictures of the restaurant, there are plenty of empty seats, but most of the tables are occupied by only 2 people. And it's situation leaving no room for new guests. So it's as the same as this assignment. So if we assign the 1 GPU to this job, the 1 GPU actually means a 4-person table, and pods are guests. So that's why we need to thinking about the GPU resource allocation very smartly. That depends on the workload and the traffic of the AI training or inference the workload. So there are some solutions. The first one is MIG, which means a multi-instance GPU. So if you see the next tag, so they say nvidia.com/MIG1G 5 gigabyte 1. This means that they only need 5 gigabyte memory GPU machine, and it's enough for this job. So if this tag is announced, the Kubernetes controller scheduler will assign only 5 gigabyte instance as a logically isolated GPU. And also it has the unique PCI ID, so it's very good to manipulate the AI workload and do not waste your GPU resource anymore. Another solution is MPS, multiprocessor service. It is a technique that you will use the one GPU, shares a single GPU context with multiple jobs. So it is a shop for AI inference workload. And MIZ, the multiple instance, the group is good for AI training. And there is another strategy called GPU orchestration. So Volcano is the famous open source for batching the job scheduler for Kubernetes, and it supports Kang scheduling, queue-based scheduling, priority queue, and etc. So most of all, the Kang scheduler is famous for ensuring all the parts in a job are scheduled together, starting together, and finish each job together. So even not all parts can be scheduled simultaneously, the entire job is held. So using the custom resource definition, you can use the Volcano for batching the GPU. So there are 8 parts, and they must be scheduled simultaneously, as the same as if we have the 4 friends, and we are going to some amusement park, and then we want to have a same line with 4 friends at the same time. So starting together and finishing together is good for GPU orchestration. So by utilizing this kind of the GPU allocation strategies, our company could save a GPU utilization improvement from 58% to 83%, and the average queue time reduced from more than the 3 minutes to 47 seconds. So eventually, it is good for saving our GPU resource, as well as we could have the low latency and then the better performance after applying this strategy. And this is my last slide. So we are monitoring the GPU performance by using the eBPF, the technologies, and we also have the good tools to monitor eBPF relevant metrics from the memory and storage and GPU and CPU. So finally, GPU scaling is critical to both performance and cost efficiency. So we adopt the Kang scheduling, MIG, MPS based on the type of your AI workload. If it is AI inference or training, you have to think about differently. So with the right strategies, you can maximize the ROI of your GPU infrastructure on Kubernetes, and you can save your GPU resource. And thank you for joining, and you can find me at the Akamai booth at G5. So if you have more discussion with me, please visit our booth, and then we can have more talk. Thank you for your time, and thank you for sticking around. See you. Thank you.